Hey guys, Sigma here. I'm going to go over Pythagorean Theorem with you guys, at least my version of it. Um, there's many proofs, so without any further ado, let's get started. Right, so if we have these three, or any 3 points really, and we know two of the distances, A and B, how can we find C? Right, so a good way of doing this, right, or a systematic way of, approaching this, right, is by making a square, right, where each side, obviously is C. So the actual square is, you guessed it, C squared, right? Now, all of this is also inside another big square, right? And it's actually not that hard because we can see that this right here is B, this distance is A, B, A, B, A, right? And it looks pretty nice. But to clean this up, what I'm going to do is I'm going to put this on the coordinate plane, right? On an XY graph. That way you guys can kind of get an idea of what happens, um, and how some things can come together. Um, all right, so here I have the graph, and we can do, yeah, we'll do y. We got our x. But there's something in particular that I want to take note of, right? It's this line right here, right? So the reason why I want to bring this up, right, is because if we look at the whole thing, right, as a whole in what we're looking at right now, we have a big square with a smaller square inside. And we also have these triangles, right? So with these right here, with the whole thing being enclosed inside a square in itself, right? What we can do is we can subtract the four areas, or the areas of the four triangles, from the bigger square. What this does is it leaves the remaining C squared, in which case all you have to do is find the root, right? Just take the square root, and that's all there is to it. But how do we actually go about this? Well, if we look at this, right, we have to take the big square, right, and then we subtract the smaller parts. So the big square is A plus B, right, times A plus B. That's area, right? So A plus B times A plus B gives us A plus B squared, right? And to get the area of the four triangles that we want, right, what we're going to do is we're going to take a look at this line that I drew before. And for this line, right, we're going to call this f of x, right? And we're going to say that is equal to mx plus b, right? So this is a linear function because it's a line, right? So in this sense, right, mx plus b, let's try to get that a little more something that actually represents what we have right here. So the first thing we're going to do, right, is let's say we look for the slope. What would you say the slope is? Right? So it goes down a certain amount and over a certain amount, just like, you know, anything else. But the way that it's looked, right, because we have A's and B's and C's, and that's really all we have. So if you guessed, you know, that it was negative A over B, then you're right. Because it's negative because it goes down, it's descending, and A, you know, and B. So what about the y-intercept? What is the y-intercept? If you guessed A, you would be correct. So let's put everything together, right? We have f of x is equal to negative a over b x plus a, right? And right now, or you know, this is really all that we need to know for us to get the area of a triangle, right? And especially on this graph, right? So let's go ahead and FOIL this out, right? What we get is we have a squared plus 2ab plus b squared. Okay, so I'm going to go ahead and move this to the top. I'm going to clear this out, and we're going to work out how we get the area of a triangle. Okay, so we have the whole area of the big square, right? And then we're going to subtract, right, the area of the four triangles. Well, when we're finding area in a graph, sometimes, you know, depending on what class you're in, we can use integrals, right? So from 0 to b of negative a over b x plus a in respect to x, right? This right here is our area, right? And so when we work this out, and we'll work it out in a second, that's what gives us the area of a triangle. All right, so I'm going to go ahead and speed through this integral real quick and see if we can get this. I'll go ahead and explain as I go, so that way, you know, you can kind of follow along, I guess. So we have negative ax squared over 2b plus ax plus c from 0 to b, right? And then, so we substitute in the upper limit first. So we have negative a b squared over 2b plus a times b plus c. So this is the upper limit, right? And so we do the lower limit, a times 0 squared over 2b plus a times 0 plus c. Right? So the c's automatically cancel each other out. And over here, the zeros, and everything's 0 on that side, so we don't have to worry about anything on that side, which is lucky for us. Over here, though, the square and the b cancel out, and that's all I can do before I have to rewrite it. And after I do so, what I get is negative a b over 2 plus ab. So I have a negative a half, and I'm adding a whole. So I'm sure you can kind of guess what I get out of it. It's ab over 2. So I get a positive 1/2. As a matter of fact, specifically, I can actually still rewrite this again as 1/2 ab. And that right there is our area of a triangle, right? And so how we put this to use, right, is whenever we have that, with that 4 that's up there, right, we do 4 times 1/2 AB, right? And so this gives us 4 over 2 AB, right? Which gives me 2 AB. Right? There we go. So that gives me 2 AB. And now I just gotta plug this in, right? So I did this, and now we have minus 2 AB. And all of this is equal to c squared. The negative and the positive cancel each other out. So all that's left, right, is a squared plus b squared is equal to c squared. All right, thank you for showing up. I'll see you next time.